For practice 1, we are going to be calculating the various components in the ANOVA table for independent samples. The only thing that we are kind of making an exception for this is the sum of squares, which you will be given in the table. So our description of our data, just so you have some context on what these values in the spreadsheet are indicating. We have a researcher who is interested in seeing if the CSU you attend has an effect on relative body fat composition, which we are abbreviating as RBFC. 172 students were randomly sampled from 4 Northern California universities: Sonoma State, Sacramento State, San Francisco State, and Humboldt State. RBFC, measured as a percentage, was estimated using gender-specific equations that factored in each participant's height and waist circumference in inches. So we are going to go to our sheet labeled Practice 1, and we will fill in the ANOVA table with the given information. The relevant equations that I'll be using for the calculations in the table can be found in the Module 7 Part 1 PowerPoint on slide 5. As a note, remember that degrees of freedom are calculated using these two coefficients, n, which represents the total sample size, and k, which is going to represent the number of independent groups that we have. So based off of this information, we already know that n is equal to 172, because that's how many people we've collected, and k, representing the number of groups, should be 4, because we have 4 independent samples that we've collected. Shifting over to our spreadsheet, I've set up the data similar to how you would see it if you were running the ANOVA yourself. So we've got a legend indicating the data labels for each of our universities. In our school column here, the data labels are corresponding with one relative body fat composition measure. So we can see there's a set of labels for each school, and there's a single relative body fat composition measure for each subject. So we should have 172 total. So we'll input 172 as our n value, and then k again represents the number of groups, and we have 4. So the first thing that we can calculate in this table, we'll start at letter A and we'll work our way to the F statistic at letter G. The sum of squares, remember, is looking at between groups and within groups comparisons. And recall in the lecture we identified that these two descriptors are different from between subject and within subject factors, which are descriptors for types of independent variable samples. So our between groups sum of squares and our within group sum of squares will always be provided to you in the table for any types of questions that you'll be answering related to the ANOVA table. Our total sum of squares is just the sum of the between groups and the within group sum of squares. So we can just put equals between groups plus, and then my cell has covered the within groups value, but if you press the up arrow and that happens to you can see this red dotted rotating box here. So I can press enter, and I've now calculated my total sum of squares. Our between groups degrees of freedom is going to be k minus 1, so the number of groups that we have total minus 1. So that'll be 4 minus 1, that gives us a degrees of freedom of 3. Our within groups comparison is going to have a degrees of freedom that is equal to the total number of subjects we have minus the number of groups we've collected. So this will be 172 minus 4. And then our final degrees of freedom is going to be equal to our total sample size minus 1. So we can say 172 minus 1. And we've got all of our degrees of freedom calculated now. The mean square is going to be the sum of squares divided by the degrees of freedom in each respective row. So we can simply do equals between group sum of squares divided by our between groups degrees of freedom. And similarly for our within groups, we can do our sum of squares divided by our within group degrees of freedom. From there, our F statistic is calculated by taking the division of our between groups mean square divided by our within groups mean square. So we just input that equation and press enter, and we end up with an F statistic. And I'm going to change that to 3 decimal places, just so that we don't have a bunch of crowded numbers in the table. I'll do the same thing for that one too. Okay, so all you're going to do is copy and paste this table into your answer sheet, and you should be good to go for practice 1.